All right, these are some notes on section 3.2. I'm sorry, section 2.1. 2.1 is talking about complex numbers, and we're also going to be looking at some factoring, some review of that. So complex numbers or imaginary numbers are solutions that involve answers that are not real. So we're used to dealing with numbers that are real numbers. They have decimals, or they're integers. We can see them on a number line, but complex numbers do not have real solutions. So a complex number is defined by this equation, x squared equals -1. So to solve that, I would take the square root. Well, we can't take the square root of a negative number, at least we haven't so far. So the square root of -1 is defined as I. So another way of thinking about this is I squared equals -1. So for imaginary numbers, there are two parts to an imaginary number, the real part and then the imaginary part. So the real part is the A portion of the number, and the imaginary part is the B. So we'll look at some more examples of those. So if I have these complex numbers and I want to solve them, the square root of -4, well, the square root of 4 is 2, and then because of the negative on the inside, it becomes 2i. So that would be the solution to the square root of -4. The square root of -16 is 4i. The square root of -8, 8 is 4 times 2, so that would be 2 square roots of 2. And then the negative would be 2i square roots of 2. The square root of -20 would be 4 times 5. Square root of 4 is 2, so it would be 2i square root of 5. So these are complex numbers or imaginary numbers here. You'll notice that you have 5 minus 11i plus 7 plus 4i. So when we're adding or subtracting, we work with these by dealing with the real part and the imaginary part. So 5 and 7 are the real parts, so we can add those together. And -11 and +4 are the imaginary parts, so we put those together and we get 12 minus 7i. Same thing here, the 11i is the imaginary part, the 4i is the imaginary part, so we add those two parts together, 11 plus 4, and we get 15i. And then the 7 just comes along with it. Here we're subtracting, so 2 minus 7i minus -3 plus 4. So that negative sign distributes just like normal, so it becomes 3 minus 4i. We combine the 3 and the 2 together and we get 5. The -7 and the -4 is -11. Same thing here. Again, that's -7. And then this becomes +9. So -7 and +9 is 2. And then 5i plus 11i is 16i. So when I'm dealing with multiplication of these two, I'm going to FOIL it just like I would any binomial. So 5 times 7 is 35. 5 times 4 is 20i. -2 times 7 is -14i. And -2i times +4i is -8i squared. So the 35 doesn't have anything to combine with. The -20 and the +20 and the -14 becomes 6. Now here's where we have to remember, I squared is -1. So right here, this is -1, and then the -8 becomes +8. So now I have 35 plus 8 is 43 plus 6i. Here's another one. -7 times -7 is 49. -7 times I is -7i. And then we get +7i right here. And then we get minus I squared. And again, I squared is -1. So all of this right here becomes +1. So I get 50. Here's just another example. Just remember that when you're squaring something, you have to FOIL it still. So this would be 2 plus 3i and 2 plus 3i. So you end up with 4 plus 6i plus 6i plus 9i squared, which becomes negative 9. So then negative 9 and 4 becomes negative 5. And then the 6i plus 6i is 12i. So one thing that I want you to see on your calculator, if you go to the mode option, you'll notice that as you scroll down to the mode, one of the options here says real, and one of them is a plus bi. So if I choose that option, and then I go back out to my calculator, if I put in one of these problems, like let's say we did this one, I can do 5 minus, and then I can say 2, and the I button is way down here on the decimal point. You see the I? So I have to do second the decimal point, and you'll notice that it says 2i there. And then I can do 7 plus 4i. And if I press enter, notice that I get 43 plus 6i, which is exactly what I got here. So you can use your calculator, you can change your calculator's mode to complex numbers or imaginary numbers, and that'll help you out some. Okay, so another example here, the square root of negative 64. 64 is 8, and then the negative would be I, so 8i. And then 25 is 5, so this would be negative 5i, or minus 5i, so that would be 3i. And I can do the same thing here. The negative 8 is 4 times 2, so the 4 becomes 2 on the outside, with the 5 becomes 10 on the outside, so 10i, square root of 2. And then this, the 18 becomes 9 times 2, so the square root of 18 would be 3 square roots of 2, and then there's already a 3 out there, so it becomes 9i square root of 2, and so that combines and gives me 19 square root of 2. Here's another one. So we have negative 18, which is 9 times 2, so the square root of 9 is 3, and then the I square root of 2, and then 8 is 4 times 2, square root of 4 is 2, so 2i square root of 2, and then again I can combine these together because they're like terms. So these are things that can help you as you're going through your problems to make sure that you're understanding what to do on these. Okay, so then we're going to do a little bit of review on factoring and solving problems by factoring or quadratic formula. So some of the different kinds of factoring, one of them is difference of squares. So difference of squares are defined by a subtraction, so these have to be subtraction. Okay, there can only be 2 terms, and they have to be perfect squares. Okay, so these 3 things have to be true. So this is a subtraction problem. X is a perfect square, 9 is a perfect square, and there's only 2 terms. So I can factor that by doing x plus 3 and x minus 3. Here's another one. 4 is a perfect square, and x squared is a perfect squared. 25 is a perfect squared, so that would become 2x plus 5 and 2x minus 5. Another one here, 16 is a perfect square, 9 is a perfect square, x is a perfect square, so I would be 4 minus 3x and 4 plus 3x. So those are one kind of factoring you need to make sure you're comfortable with. Here's another kind, this is called grouping, and grouping usually happens when you have 4 terms. And usually what happens is you can group the first 2 together and the last 2 together and then factor them. So on this one, if we group the 6y cubed and the 21y squared together, they have a 3y squared in common. So I'm factoring out the greatest common factor. So then I'm left with 2y minus 7. So remember, if I distributed this back in, 3y squared times 2y would be 6y cubed, and 3y squared minus 7 would be 21y squared. I'm sorry, I gotta get rid of my cat. Okay. So then I can do the same thing on the right-hand side. There's a 4y and a 14 here. So they have a 2 in common. I can factor out that common 2. And then I'm left with 2y minus 7. Again, if I distributed, negative 2 times 2 is negative 4. And negative 2 times negative 7 is 14. So now what happens is you'll notice that these two terms are the same. So if I factor those out, and then I write down what I'm left with, 3y squared minus 2, this is factored by grouping. Okay, now if I did FOIL it back out, 2y times 3y squared is 6y cubed, 2y times negative 2 is negative 4, and then there's that negative 4, and then negative 7 times 3 is 21y squared, and negative 7 times negative 2 is positive 14. So I could distribute that back out and get the answer that I started with. Okay, so here's two more examples. This is supposed to be an x. I'm sorry, I had a typo. So I have 3x cubed plus x squared plus 6x plus 2. If I factor the first two and the last two, these two have x squared in common, so I take that out, and I would be left with 3x plus 1. You got to remember to leave that 1 behind, because I need to be able to, I should be able to distribute this back in and get what I started with. These two have a 2 in common, so I am left with 3x plus 1. Now our goal is always to end up with the same thing here. So if we don't, then maybe we didn't factor it correctly, or it can't be factored. So you have to keep that in mind. So I'm left with the x squared plus 2, and I rewrite the 3x plus 1 as its factor by itself. And there's my factor. We have one more here. Again, factor the first two. They have a 3 and a w squared in common, so I'm taking that out. So think about 3 times, or 18 divided by 3 is 6, and w cubed divided by w squared is w. 15 divided by 3 is 5, and w squared divided by w squared is 1. So this is factored out here. This is a 5. Here I'm going to have a 2 in common, so if I factor out a 2, 12 divided by 2 is 6, and 10 divided by 2 is 5. So notice again I've got the 6w plus 5 in common, so I can factor that out and write down what I'm left with, 3w squared plus 2. So these are factoring by grouping. Watch the second video to get some more help on factoring.